Hey everybody, we're going to talk about confidence intervals today. And with confidence intervals, uh, again, we're moving to the section in our course where we're talking about predictions, making predictions, and we want to make the most accurate prediction that we can possibly make. Up to this point, what we've talked about with predictions, we've talked about a point estimate, like saying, for example, that the mean is 82. Okay, well, it gives us a starting point, gives us one piece of data. What a confidence interval is going to do is it's going to give us a range of data. Okay, that's why we call it an interval. For example, we might say that we believe our scores are going to be between 77 and 87. And what we tie with that interval is a confidence rating to it. The most common confidence ratings that are used are usually 95%, 90%, 98, 99. Those are usually the four most common ones. So if we say that we're 95% confident that our score is going to fall within this range, what that basically is saying is that there's only a 5% chance of error that it's going to fall out of that range. So that's why statisticians prefer to use a confidence interval over a point estimate. Okay, because again, you have that confidence rating. You know that that margin of error is going to be very, very small. And the question that people always ask is, well, why don't I just always use a 99% confidence interval? Why would I always want to be 99% confident and only have a 1% chance of error? Well, again, the reason why you want to be at that 95% compared to 99 is, well, that interval is going to get larger. For example, we could use a 99% confidence interval, but for this particular sample, then my range might jump out to 72 to 92. Okay, so that's the give and take that you take. Do you want to be 99% confident and have your range be a little bit larger, or do you want to have a tighter confidence interval and be acceptable with 95? That, as a researcher, that's what you have to decide what you want to use. For our particular class, the confidence interval is always going to be given to us. Okay, so what we're going to do today is we're going to figure out, well, how do I come up with this range? Okay, how do I come up with that final answer? And to find a confidence interval, what we are going to need to do is talk about what the formula is going to relate to. Okay, so we're going to be starting off with a point estimate, a sample mean. And in order to get that interval, to get that low end and that high end, we're going to be doing a plus minus. Okay, and the way I'm going to classify it is in our formula. Okay, what's the z-score that we're going to be using? And then the third piece in the formula is our standard error, our standard deviation divided by our sample size. So in all the problems, they're going to tell you a confidence interval. Okay, for example, in that last problem, we used a 95% confidence interval. So if you think about that on our curve, a 95% confidence interval means, again, that there's a 5% chance of error. 2.5% in this tail, 2.5% in that tail. Okay, 95% of the scores are going to fall in this range, whatever our two scores are. Okay, well, in order to find the z-score, again, if I looked up the area to the left, if I looked up 0.025, my z-scores would be 1.96. So that's what I would use in my formula, is 1.96. Okay. Now, if we wanted to do a 99% confidence interval, which I'll do in black, okay, 99% means we would have a 1% chance of error. And if you cut 1% in half, that's 0.005, a half a percent. If you look up that value, that is a z-score of positive and negative 2.58. And that's what we would use as our z-score. So depending on what confidence interval you are given, okay, that's going to determine what z-score we're going to use. And again, the most common ones are 90, 95, 98, and 99. But we could use this strategy to find any confidence interval. If it was 94%, 6% chance of error, 3% in each tail. If you look up 3% in your table, that's how you find your z-score. Okay, so that's the first thing that we need to know how to do with our formula. Now, what we're going to look at is an actual example. So the paper that we're going to be using for this one is the one that says lesson 8.1, 8.2 confidence intervals, which I have uploaded to your Google Classroom. And the first example, what I've kind of done is I've kind of laid it out into pieces. Okay. So the first piece, it says an effort to estimate the mean amount spent per customer for dinner at a major Atlanta restaurant. Data was collected for a sample of 49 customers over a 3-week period. Okay, so the first thing out of that information is we know our sample size is 49. Okay, assume a population standard deviation of $2.50. Okay, so the first question is, what is the standard error of the mean? Well, if you take 250 and you divide it by the square root of 49 or divide it by 7, that's going to come out to 0.36. And again, that piece of the formula, that's called the standard error of the mean. Okay, the second piece, okay, at a 95% confidence, what is the margin of error? Well, because they told me 95% confidence interval, we're going to use 1.96. Okay, just like we talked about. Okay, looking up that 0.025 in your table. So when I multiply my z-score times my standard error, I come up with what's called the margin of error. And that margin of error, in this case, since we're talking about money, we're going to round it to 2 decimal places. 70 cents is the margin of error. And then the last piece is the sample mean is $22.60. So, okay, that's what we're saying the average price is. Okay, the margin of error is what we're going to add and subtract to that value. So if I subtract 70 cents from $22.60, I'm going to end up with $21.90. And if I add 70 cents to $22.60, I'm going to end up with $23.30. So this is our confidence interval. Okay? What we're saying is that we're 95% confident that if we go out to lunch, that's what the price of the lunch is going to be. It's going to be in that range. There's only going to be a 5% chance that it's going to be less than $21.90 or greater than $23.30. Again, based on this sample of 49 customers. So we kind of chunked that. Okay, we did it backwards. But again, you have to identify 4 pieces in your formula. What's the sample mean? What confidence interval did they give me to find the z-score? Standard deviation and sample size will always be given. Okay, so we're kind of working backwards when we solve these problems to come up with our confidence interval. Okay, if we take a look at number 2, it says the average annual wind speed in Rochester, Minnesota is 13.1 miles per hour. So that's our starting point. That's our sample mean. Okay, a sample of 100 days. Okay, so sample size is 100. Okay, find the 99% confidence interval. Again, 99% confidence interval is going to be a z-score of 2.58. And the last piece they give us is the standard deviation is 2.8 miles per hour. So again, if we do 2.8 divided by 10. The standard error is going to be 0.28. And we're going to multiply that by 2.58. And when I multiply that, I'm going to end up with a margin of error of 0.7 miles per hour. Now, a question a lot of people ask is, well, how come I left that as 1 decimal point? Whatever my sample mean is, that's what I'm going to have my margin of error in the same decimal points. Okay, when we're talking about money, it will always be 2 places. If the sample mean was a whole number, like it will be in number 5, well, then you make your margin of error a whole number. So when I add this, 13.8 miles per hour. When I subtract it, 12.4 miles per hour. So again, for this example, we're 99% confident that that's going to be the wind speed. So if someone's going to say to you, well, the wind speed is going to be 16 miles per hour. No, it's not. Okay, there's only a 1% chance of that happening. So we're very confident in this interval. Okay, 99% confident that the wind speed is going to fall in that. And again, that large sample size helps with that confidence interval, and also choosing a 99%. So that is how we set up a confidence interval problem. And on that sheet, I'm going to let you do 3, 4, and 5. Thank you.